How's it going, ladies and gentlemen? So today we are going to solve another coolest problem, Leetcode problem 11, containing with most water. Okay. So what the problem statement is saying, we have given something like an input array outside this, and we have to find the maximum water you can fill in this kind of a beaker. Okay. So these are just thinking like these are buildings, and you have to fill the most water you can fill in these buildings. Okay. So, and remember one thing, the water does not have to go overflow. Okay. So be sure about that. Okay, so the problem statement is quite simple. The problem is medium level, but it's actually I feel that's a medium level problem here, because initially the problem makes you a little bit think about, but the code you're gonna do it is way easier. Trust me, you will love it. You will say like, dude, I'm so stupid, like I can't code it up. Trust me. Okay, you are not stupid. Okay, so anyways, let's just move on. So first of all, what the flow is, we're going to talk about problem statement, then we're going to talk about how to approach it, and then finally we're going to code it up. So code both in C++ and Java is available in the description section link. Just check it out with a beautiful article. So this problem, I have written an article on this problem as well on the Leetcode. So check out the link, you will, if you have not seen that. Okay, here we go. So first of all, again, let's just see what the problem statement. We have given this kind of heights of buildings, okay, and we have to fill maximum water I can fill over here. Maximum water I can fill in between them. I have to fill that water in between them. I can fill. Okay, so the maximum amount of water I can fill, and I have to written that. So how are we gonna check it out? Now you will say now you will say, first of all, dude, like you represent these two buildings with red marks and the other one with black one. So I will say, we're gonna check it out, don't worry. So you will say the maximum building which I can find is the 8 and 8, but if I fill the water over here, then I will get the maximum one. I will say, okay, so if you're gonna fill it like this way, so you saying like the 8 and 8 are the maximum one. Okay, so if I gonna fill this one, only fill this one, so what will happen? What is its length? So I will just calculate the beaker length. The beaker length is 8. I will get the minimum one. So I will get the minimum beaker length, which I get is 8. Okay, so you can see, yeah, 8,8. So the minimum beaker length I can get is 8 from over here. And what is the breadth? That's the breadth. I'm so sorry. That's the breadth. Like, you know, we're gonna generate a similar formula which you already know, the area of rectangle. We're gonna generate the same formula by using that. Okay, and our length is what? Our length is this one length from this position to this position. So I will gonna subtract 6 minus, which is 5. So now I will gonna get the area. Area is L into B. Length to breadth. Length is 5. Breadth is, I've got the minimum is 8. So which is 40. So is 40 enough? I will say, okay, we got something greater one. But what if the question is saying like till over here? If I fill the water till over here, then what's the length and breadth, the area which will I get? So we want to do that. So if I fill it till over here, so now my new breadth will be 8,7, the minimum one. So which is 7. So I will get the minimum of 7, and the length, my new length is what? 8 minus 1, which is 7. And if I calculate their area again, which is 7 into 7, L into B, which is 49, and 49 is greater than 40. I hope so you got the idea, like how I'm thinking of. Like I'm just thinking like just take it as a, like, you know, a simple math formula, area of length into breadth. That's how we gonna approach it. So I'm just talking about the approach, the code. The problem simply is very simple. Like you just have to fill the water over here. So I don't think there's nothing more to talk about the problem. Okay, guys. Now some of you may have think it like the problem trapping rainwater. It's not that one. We want to solve that one as well, but it's not that one. Okay. Initially, I just think the same. Initially, I think the same. Like, yeah, this is the another, I think, trapping rainwater problem, so we can do it like that. But no, I was wrong. Okay. Alright, guys. So I hope so the problem statement and approach is clear. Like how we are getting. So for example, now you will say, but how we gonna do it? That's the main thing. How we gonna do it? So what I will do? Let me just gonna draw it again over here. The one more time. Let me gonna draw it, and for that time, let me just pause this video. Okay, guys, so I just have drawn this following diagram for you guys. Okay, so now what I'm gonna do, how I'm gonna approach it. So I will create 2 pointers. I will use 2 pointers. So my one initial pointer I will be at over here on the 0th index, and my j pointer will be at my last index. Okay, in this way. Now what I will do, I will first of all get the minimum length. So sorry again about the another cut. I'm so sorry. Okay, so where we are, okay, so we have created two pointers, I and J pointer. We have created two pointers, I and J pointer. So how I am moving and how I am getting the things. So first of all, what I will do, I will get their length. So their length is this one. So first of all, I will get their length. So I will create one length one. I will create one length variable, which is 8 minus 0, which is 8. And then what I will do, I will get their another breadth. So breadth will be my, how I will get the breadth. I will get the minimum breadth. I will get the minimum breadth from this J1 and I1. So which will be 1, 7, which is 1. And you know the area, how I calculate length into breadth. So length is 8 and breadth is 1, so 8. And we will create one max one to hold the maximum. Till now we have got, so till now our max is 8. So like previously our max is 0, so now it's get updated to 8. Okay, so we get our max. Now how we gonna move it? The main thing is how we gonna move it. So to move this one, what I'm thinking is, I will check which one length is higher. I will keep them over there, and the smaller length one will gonna move. Okay, so in this one, the I pointer has the small length, so it will gonna move. So it will gonna move over here. The I pointer will come over here on pointing on 1. Okay, now I will again do the same thing. So I will now again gonna calculate their one. So 8 minus 1, which I will get is how much? 7. Okay, and the breadth, the minimum breadth, so 8,7. The minimum breadth I will get from over here 7. Now the new length is 7 multiply 7. So the 7 is length and 7 is breadth. So 7 multiply 7, which I will get 49. And 49 is greater than 8 previous max, so we're gonna update it to 49. Okay. Now over here the I pointer length is I pointer breadth is greater. So the 8 height is greater. 8 height is greater as compared to 7th height. Okay. So what I will do, I will gonna move my J pointer now. Okay. Because now my I pointer height is greater. Now over here, I will again gonna calculate the length and the breadth and the same thing over here. So let me calculate for this one as well even. So our length will be what? 7 minus 1. 7 length is 7 minus 1, which will get is 6. So our length is 6, and the breadth we get. The breadth is minimum of from 3 and 8. So the breadth we want is breadth is from 3,8. So 3,8, which one we get is 3. Okay, so if I multiply it 7 into 3, so the area we get, current area we get 7 into 3, which will be 21. Okay guys, all right. Now, okay, what we have to do, 7 into 3, 21. So now we will check, is our area is greater than our max? So it will say no, it's not greater, so we're gonna ignore 21. So now I will gonna move my J pointer because still I pointer height is greater, so J will move over here. Okay. So now J is pointing to the height of this this tower of at 6 index. Okay. Again, I will gonna check which one is which one is minimum. So it will say like minimum from this one 8,8 is 8. So we get our breadth, which is 8. Our breadth is 8, and our length how much we will get. So which is will be 6 minus 1. 6 minus 1, which is 5. So our new area we get is 8 into 5, which is 40. Is 40 is greater than 49? It will say no, it's not, still not greater. So we're gonna again move it. Now over here you see we have 8 and 8. Which one is greater? Which one to move? IJ pointer will stuck over here. So if we find the height similar, we will get one more case. If the height are similar, then what I will gonna do? I will move my I pointer and I will move my J pointer even as well. In this case, I will gonna move my both of the pointers. Okay. So that's how it's working. So that's how you're gonna traverse it. Like once they gonna intersect, like once they are appearing to intersect like this, we're gonna stop our loop. So that's how we're gonna solve this problem. I hope the approach is clear. If it's still not, don't worry. I haven't added a beautiful article as well in the description section. You can check it out, but watch the video first of all. So now it's final time to code it up. So for example, in our code we have given something like public int whatever, like let's say height, and inside this they are given a nums array. Okay, and in this one what I will do, I will check I will create my first pointer I, which is pointing at 0, and my j pointer is pointing at my last value, nums.length -1. Okay guys, I will create one max pointer, max variable, which is initially 0, while I less than j. While they don't intersect, I will gonna run my loop. Okay, and in this one, what I will do, I will first of all say, do one thing, get the breadth. So breadth will be, how we get the breadth? So it is math.min of either nums of I or nums of j. So that's how we are getting. I hope so you know this thing, as I told in the approach. And length, what we are getting, the length is simple, j minus i, that's how we're getting. And what's the area? You know the formula, area, man. I know you know the formula, which is length multiply breadth. Okay, and finally update our max equals to math.max of whatever we get, either previous max is greater or area is greater, whichever we get, we will gonna get it from over here. Okay guys, I hope so this thing over here is absolutely clear. Now we have to deal with a few things over here as well, so just give me a second. Okay, yeah, now we have to move our I and j pointer. So how are we gonna move? I will check if my nums of I pointer is greater than my nums of j pointer. So if my I pointer greater than my j pointer, then I'm going to simply decrement my j pointer, just move the j pointer because I is greater one. Okay, so we don't have to handle them right now. If my nums of I is smaller than my nums of j, then what it means, increment your I pointer, move your I pointer. Else if, what could be else if? My nums of I is equals to my nums of j. If their height are similar, if their height are exact similar, then do one thing, increment your I and decrement your j. You have to move the 2 pointers. Okay, you don't have to deal with any single one. You have to take care of both of them. Okay, and finally, out of this for loop, what you have to do, you have to simply return your max, whatever the max you will get. And that's how we have solved this problem. I hope so, ladies and gentlemen, this thing is absolutely clear. This problem is a beautiful problem to understand. Like it's a kind of the math problem, just use of mine. And yeah, I know you are smart enough. So that let's just talk about time complexity over here. In this one, we are dealing with big O of n, as we are just iterating over the complete array n times. Okay, and the space complexity is big O of 1 because we are not using any extra memory over here in this code. So I hope so, ladies and gentlemen, this code is absolutely clear. And I'm again saying Java and C++ code with article is available in description section. If you have watched it over here, thank you very much for watching this video. I will see you in the next one. Till then, take care, bye bye, and I love you guys. Believe me, I love you. Take care, bye bye.